For ethers, they can be either symmetrical or unsymmetrical. And the functional group is the oxygen in there. This is the general formula of the ether. If the R's are the same, then these are symmetrical. If they are not, then they are unsymmetrical ethers. For naming ethers, this is an example of a symmetrical ether. And we normally name, this is a small ether. And for smaller ethers, we prefer to name them as common rather than IUPAC. It's easier. So the name for this one is going to be a diethyl, and then the ending is going to be ether. There is a space between the diethyl and the ether. So there is a space over there between those two names. Okay, so the rule says that whenever you are naming an ether as common, you just name the R group in there and you put the word ether at the end. You keep a space between the R group and the ether. Now, all of these are smaller ethers, and those are easily named as common names. This is an example of an unsymmetrical ether. And you can easily see it's an unsymmetrical ether because the R's are different here between the oxygen. So that is an unsymmetrical ether. In this case, you are going to name still the R's, put the word ether at the end, but you have to arrange the R's in alphabetical order. So I know that this side is a butyl group, because count the carbons, it's 1, 2, 3, and 4. And the other side here, it is an ethyl group. B comes first, so the name here is going to be butyl. Put a space, and then an ethyl. Put another space in there, and then the last is going to be ether. Okay, so you do have spaces between each of these names. Again, this is an example of an unsymmetrical ether, so I'm going to name both R sides in there. As we said, symmetrical ethers, you just put the prefix di in there, and then you combine the R's and put the word ether at the end. So let's name those groups. This is going to be an isopropyl. And on this side, this one is a tertiary butyl. We alphabetize starting from the B. And here I'm going to alphabetize the I. So I'm going to start the name with a tertiary butyl, space, and then isopropyl, another space, and then I do have my ether. For naming ethers in IUPAC, this is for larger ethers in there. I'm going to go ahead and name them as an alkoxy. So if I have an OCH3 in there, it's going to be a methoxy, ethoxy, propoxy, because this is a propane that is connected to an oxygen. So I'm just going to name it as an alk. Alk is the alkane, and then drop the ANE and add the oxy there. This is a tertiary butoxide, so I'm just going to go ahead, and add an oxy, drop the ending, and add an oxy. It will be tertiary butoxy in there. If you look at the trend of the naming or the priority of the naming, when we wrote the priority order in there, ethers is even lower priority than the alkane. So whenever ethers are present next to the alkane, ethers are named as an alkoxy, and they are considered to be substituents on the alkane chain. Okay, so never, ever, ever the ending is going to be in the ether. So let's have an example of those that we named as common. Now we're going to name them as IUPAC. These are still small ethers in there. So the rule says that you have to choose the R side that has the highest number of carbons. Here in this case, both sides have 2 carbons, so I'm just going to choose one. And I'm going to treat the OCH3 to be a substituent. Okay, so that not OCH3, I mean the OR in there, that is going to be a substituent on the chain, and I'm going to give it the lowest number. So that's why I'm going to number 1, 2 over here, and the name is going to end in ethane because it's a 2-carbon chain. So that is going to be an ethane in there. And on carbon number 1, I do have an ethoxy. Why it's an ethoxy? Because it's an ethyl group connected to an oxygen. So that is going to be ethoxy. Ethane and ethoxy, ethane is just one word in there. Normally, this is diethyl ether. It goes by its common, not its IUPAC. So to name this structure as an IUPAC, all I need to do is look at the R chain and choose the longest R chain. Here, both R chains are the same. They are made up of 2 carbons. So I'm just going to go ahead and choose one and treat the OR that is on the chain to be an alkoxy substituent. This one is a 2-carbon chain, 2-carbon OR. So that is going to be an ethoxy. I'm going to name it an ethoxy, and I'm going to give it the lowest number in there. That rests on the ethane, so my ending is going to be an ethane. And on carbon number 1, I have the ethoxy. So drop the 1, and the name is going to be ethoxy. Ethane, there is no space between ethoxy and ethane. This is diethyl ether as common. It goes by its common. It doesn't go by its IUPAC. It is a solvent that normally we use in organic in order to dissolve organic compounds. This is another example over here. All of those are small ethers that go by their common rather than IUPAC, but you have to know how to name them in IUPAC. So again, the rule says that I'm going to choose the R chain, which is the longest. So this one is a 4-carbon R chain in there. So my ending is going to end in it, which is butane. And then on carbon number 1, so I have to give the OR the lowest number because it's the only substituent in here. If it is not the only substituent, then I would go by alphabetical order, or I would go by the rule that says that the first substituent needs to always get the lowest number. So that's going to be 1, 2, 3, and 4. On carbon number 1, I do have an ethoxy as well. So that is going to be my ethoxy on carbon number 1. Let's write that, and it's going to be ethoxy. And again, there is no space between the ethoxy and the butane. So let's go ahead and bring the butane all the way there, so that we eliminate that space. It's all one word. For this structure, again, we're going to choose the longest carbon chain, and always choose the longest carbon chain with the most substituents. Okay, I have here 3-carbon chain, and I also have here 3-carbon chain. But if I choose the 3-carbon chain here, I'm going to end up having one big substituent. On the other end, if I choose this longest carbon chain, which is still 3 carbons, I'm going to end up having 2 substituents. So always choose the longest carbon chain with the most substituents. This is always the rule. It was the rule for the alkane when we were naming alkanes as well, and we're going to keep it a rule every time we are naming organic compounds. If you have 2 routes that give you the same carbon chain, then you have to go with the route with the most substituents in there. So now I have 2 substituents on it. I have a methyl group. And over here, I do have my isopropoxy group. This one is an isopropoxy group in there, arranged in alphabetical order. So on carbon number 2, I have an isopropoxy. And on carbon number 2 as well, I do have a methyl. And then your chain in there, which is going to be 3-carbon chain, it is propane. Okay. So let's have another example. Now, in this example, I have a longer carbon chain. So here, always name it as IUPAC in there, and make sure that your ending, since I have the OCH3, I have the chlorine, so definitely my ending is going to be in the alkane. The OCH3 is going to be my substituent. So you're going to choose the longest carbon chain that includes as much substituents as you can. So here I'm going to go with this route. I'm going to go with this route rather than this route over here, because I want the most substituents. And if I go by this route, I'm going to end up having 1, 2, and 3 substituents there. My substituents here are going to be the chlorine, which is the chloro. It's going to be the propyl group, and it's going to be the methoxy group. I need to arrange them in alphabetical order and give the first substituent the lowest number. Here I would need to go by 1, 2, and 3. So if I go by 1, 2, and 3 in there, this is the same as 1, 2, and 3. Both substituents, they get the lowest number. Then I would need to number from the side to give the second substituent the lowest number. So the second substituent here is going to be my ethyl group. That's going to be on 4 rather than 1, 2, 3, 4, 5. So I'm just going to go ahead and number from here. You don't go by alphabetical order unless you have a tie with the numbers, then you go by alphabetical order. So that is going to be 1, 2, 3, that is going to be 4, that is going to be 5, and that is going to be 6. And the name here is going to be, let's put it down. It's going to be on carbon number 6, I do have a chloro. And on carbon number, arranged in alphabetical order, methoxy comes before propyl. So on carbon number 3, I have a methoxy in there. And then on carbon number 4, I do have a propyl. And then my ending, this is 6, this is 7, and this is 8. It's an 8-carbon chain, so it's going to be octane. Do the same thing over here. Choose the longest carbon chain, including, now notice here that I have OH. And if I have an OH has a higher priority than the OCH3. So definitely now my ending has to be in the alcohol, okay? And I need to give the alcohol the lowest number. So I have no option but start numbering from here in order to give the OH the lowest number. That's going to be 1, 2, 3. The OH is on 4. The 2 CH3s are on carbon number 7 in there, and this is 8, and that is 10. So what I have here is 2 methyls on 7. So these are my 2 methyl groups in there. I do have a methoxy. Sometimes it really helps when you circle and you name those substituents before you go ahead and you put the name in there. and this is going to be my ethyl group. Okay, so I've named everything. Now let's arrange them in alphabetical order. The E comes first from the ethyl, so the name starts with 8-ethyl. On carbon number 3, I have a methoxy. Methoxy comes before methyl. The meth is a tie, so between the Y and the O comes first in alphabetical order. So this is why I have the methoxy. And on carbon number 7, I have 2 methyls. So that's going to be 7,7, and it's going to be a dimethyl in there. If you put just 1 7, the name is wrong. Every substituent needs to have a number. And then on carbon number 4, I have the OH, so that is going to be 4 decan, drop the E and put an OL. Or instead of doing this, I can do a decan for O. Whatever you want, both are going to be right. Now for cyclic ethers, there are different types of cyclic ethers. There are different members of cyclic ethers in there. What we are interested in is the epoxide. Epoxide is the simplest ether, and this is a 3-membered ring ether. Membered ring ether. This is going to be the simplest ether in there. And then we have the 5-membered ring ether. And when I say membered ring, I mean the atoms that are included in the number of atoms that are included in the cycle. So here what I have is the oxygen. This is 1 atom, and then carbon, and then a carbon, and then a carbon, and the carbon. So 4 carbons and an oxygen makes a 5-membered ring. Same thing here, an oxygen and 5 carbons, they make a 6-membered ring. So this structure there, this is a cyclic ether, which is made up of a 6-membered ring. Later on, when we start with carbohydrates, cyclic ethers of furan and dipuran are the ones that we are interested in drawing the carbohydrate structure. So we will hit on those again.